In this video, we start looking at the four fundamental spaces of the B matrix. So recall the Tonti diagram. U delta F P. Suppose there are n degrees of freedom in the structure and m members, so that U and P are in Rn and delta and F are in Rm. So B is m by n. So B takes Rn to Rm and B transpose takes Rm to Rn. We can construct the four fundamental spaces of the B matrix as shown here. So Rn can be partitioned like this and Rm can be partitioned like this into the column space of A, B, the null space of B, the column space of B transpose, and the null space of B transpose. And remember the perpendicularity relationship. Let's now interpret the four fundamental spaces of the B matrix. First, let's look at the null space of B. So if a vector is in the null, and this is a kinematic interpretation. So if a displacement is in null space of B, that means B times that displacement is 0. So that displacement doesn't produce any changes in lengths of any members. This means that that displacement corresponds to a rigid body motion, or it corresponds to an internal mechanism. Internal mechanism is some loose part inside the structure. Next, let's look at the column space of B. Again, this is a kinematic interpretation. If a delta is in the column space of B, this means that change in length can be obtained from joint displacement. Such changes in length are called compatible deformations. If a delta is not in the column space of B, what does this mean? It means such a delta can only be achieved if the members break away from the joints. These are incompatible deformations. Next, let's look at the null space of B transposed. And this is a static interpretation. Static interpretation means it's got to do with forces, and kinematic interpretation means it's got to do with displacements and changes in length. So if an internal force is in the null space of B transposed, that means B transpose times that internal force is 0. This means these internal forces are self-equilibrating. That means because B transpose F is 0, there are no external forces. So such internal forces in the null space of B transpose correspond to things like temperature changes, pre-stress, fabrication error. And you recall that we looked at temperature change in the first assignment. Next, let's look at the column space of B transpose. This is a static interpretation. It's got to do with forces. The column space of B transpose are those external forces that can be hit by B transpose. This means these are external forces that can actually be supported in equilibrium. So we understand what the different elements of the four fundamental spaces actually mean. So let's make some notes here. Suppose the dimension of the null space of B is greater than 0. That means there are possible rigid body displacements and possible internal mechanisms. That means the structure is unstable. But if the null space of B, the dimension of the null space of B is greater than 0, that means the dimension of the column space of B transposed has to be less than n, because the sum must be equal to n. The sum of the two dimensions must be equal to n. And this means Not all external loads can be supported. So if the structure is unstable, not all external loads can be supported. Now, if the null space of B transposed, its dimension is equal to 0, that means the structure is statically determinate. And this also means that the dimension of the column space of B is equal to M. And this means that any combination of changes in length of members can be obtained from the joint displacements. And we also observe that the dimension of the null space of B transposed is the degree of static indeterminacy of the structure. Now, what we've said so far is kind of the most useful interpretation of the four fundamental spaces. But there is also a possible alternate interpretation of the four fundamental spaces. And in this alternate interpretation, what was a kinematic interpretation before will become a static interpretation, vice versa. So in this alternate interpretation, let's look at the null space of B first. So if a certain external force vector P is in the null space of B, that means P is not in the column space of B transposed. That means such a force cannot be supported by internal forces. So such a P is an external force that cannot be supported by the structure. Next, let's look at the column space of B. So if a member force vector F is in the column space of B, that means it's not in the null space of B transposed. That means B transposed F is not equal to 0. So this means these are not self-equilibrating internal forces, but these are internal forces that actually equilibrate external forces. Next, let's look at the null space of B transposed. Now, this is a kinematic interpretation. Suppose a delta, a vector of changes in length, is in the null space of B transpose. This means delta is not in the column space of B. So such a delta is an incompatible deformation. Cannot be achieved by simply moving the joints. Lastly, we'll look at the interpretation of the column space of B transposed. This is a kinematic interpretation. So suppose a displacement is in the column space of B transposed. That means it's not in the null space of B. And these are displacements that do produce changes in length.